Why game performance will make or break your career. Hello and welcome to episode number 4 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever noticed how in most studios, 1 or 2 developers become the go-to people whenever performance falls apart? They're the ones management calls in when frame rates tank 3 weeks before launch. They get promoted, they get the interesting projects. And here's the kicker. Most devs avoid performance work because it's hard. Sounds familiar? If so, this episode is for you. Today we're laying out the full roadmap for becoming that go-to performance expert. We'll cover why performance isn't optional anymore, the 4 pillars that hold up every shipped game, and the exact optimization loop you'll use to solve any bottleneck. Let's start with the uncomfortable truth. Bad performance kills games. Not in a vague, oh that's unfortunate way. I mean actual commercial death. Batman Arkham Knight had to be pulled from Steam. It took months, maybe years to recover from that launch disaster. Cyberpunk? The PlayStation 4 meltdown was so bad Sony pulled it from their store. These aren't indie projects with no QA budget. These are AAA titles backed by millions of dollars. Now maybe you're thinking, sure, but I'm not making Batman. Fair enough. But every platform has a performance bar you have to clear. Oculus Quest requires a constant 72 frames per second. Miss that and you don't ship. Period. And that's just the start. As hardware evolves, those targets go up. Quest will demand 120 FPS soon enough. Even if you're targeting Steam, performance affects your revenue directly. Negative reviews mention poor frame rates. Players refund games that stutter. And unless you're paying for front page ads, which is a terrible investment if your game runs at 20 FPS, you need that organic social proof. Good performance leads to positive reviews lead to visibility leads, you'll get the idea. But here's the part most people miss. Performance expertise makes you professionally valuable. In my experience across multiple studios, developers actively avoid performance work. It touches too many systems. It requires understanding hardware, not just code. It's hard. So when you become the person who can diagnose a GPU bottleneck or shave 15 milliseconds off the main thread, you become indispensable. Want a promotion? Ship a game that holds 60 FPS on minimum spec. Want a new job? Put optimized rendering pipeline, reduce frame time by 40% on your resume. Performance is a career accelerator, plain and simple. And if you're in VR, performance isn't just about good reviews. It's about not making your players physically ill. I once spent weeks on a project running at 15 frames per second. I got sick every single day. One time Unity swapped the left and right eye rendering. Worst experience of my life. Took 2 full days to recover. That's what bad VR performance does to humans. So why don't more developers master this skill? Because game performance is genuinely difficult. It's not just about writing fast code. You need to understand the hardware underneath your platform. As someone with a computer engineering background, I can tell you this is not a weekend tutorial topic. Teams also underestimate the effort required. Shipping a high-performing game can take months of focused optimization. I've lived this project after project. Porting Star Trek Bridge Crew to Oculus Quest required a huge effort. And most teams make it worse by leaving performance work until the end. Unity and Epic both say the same thing. Optimize from the beginning. If you wait until beta, you risk spending months or years fixing what you could have designed correctly upfront. There's also the scope problem. Performance is broad. It includes CPU, GPU, memory, bandwidth, build times, and even developer productivity. Yes, developer performance counts. How much time are you wasting waiting for builds? How much technical debt slows down every feature? That's part of the performance equation too. And here's the final reality. You're never finished with performance. Even after you ship, Android or Oculus can push an OS update that tanks your frame rate. Then you're back in the trenches. Plus, you're probably not making just one game in your career. Every new project needs performance expertise. So what's the plan? Inside the Performance Task Force program, we focus on 4 pillars. Every game or experience must have all 4 optimized. Let me walk through them. Pillar 1. Professional performance. This is about saving time and improving quality. We cover modern C#, so you write efficient code efficiently. Notice the difference? It's not just about the runtime speed of your code, it's about how fast you can write and maintain that code. We also tackle build pipelines, because waiting 2 days for a build to compile destroys productivity. You'll learn about cloud delivery, analytics, game architecture, patterns that save time, all based on what actually made the difference in my teams. Pillar 2. CPU performance. This covers your main thread, render thread, audio system, job system, dots, UI, physics, anything that runs on the central processing unit. Most frame time problems live here, so we'll spend serious time on this pillar. Pillar 3. GPU performance. This is all about your graphics card. Vertex shaders, fragment shaders, maybe some geometry shaders, though those are less common now. We'll tackle overdraw, which affects your fill rate budget. And we'll cover techniques specific to augmented reality and virtual reality, where GPU performance is even more critical. Pillar 4. Memory performance. We treat memory broadly here. Yes, we include RAM usage, but we also cover memory bandwidth, the data you transmit between hardware units each frame. Reducing bandwidth cuts loading times, which directly affects player retention. We'll also look at install size and build size optimization. If you distribute via APK, this matters a lot. Now, before you start optimizing anything, you need to define your performance goal. Be specific. For example, my shooter must run at 100 FPS on these 2 specific GPUs, with a maximum memory budget of 2 GB and a load time under 4 seconds. Once you have that goal, you execute the P3 optimization loop. This is the process we use at TheGameDev.Guru for every performance project. Step 1. Profile. Gather data about where you are right now. Find your bottleneck. Identify who's causing it and why. No guessing, just numbers. Step 2. Plan. Brainstorm at least 3 options to improve performance. Why 3? Because your first idea is often the worst. For example, your first thought might be, the scene is complex, so let's reduce the number of enemies. Congratulations, you just screwed up the designer's work. By forcing yourself to brainstorm multiple options, you find better solutions that don't compromise the game design. Step 3. Perform. Execute the strategy or strategies you selected, implement the change, measure the result. Then you loop. Every iteration of the P3 process gives you a significant performance boost. Guaranteed. Finally, after you hit your goal, do a performance retrospective. Create 2 lists, things to do in the future and things to avoid. This is how you capture wisdom. This is how you make sure you and your team don't repeat the same mistakes on the next project. Along the way, we'll use a ton of different tools. Unity Profiler, Frame Debugger, RenderDoc, various platform-specific profilers. I want this program to be intensely practical. The more tools in your toolset, the more flexibility you have when you hit a real-world bottleneck. Let me recap the key ideas. First, game performance is non-negotiable. It affects reviews, sales, platform approval, and player retention. Bad performance kills games and careers. Good performance builds them. Second, the 4 pillars are professional performance, CPU performance, GPU performance, and memory performance. Every shipped game needs all four optimized. Third, the P3 optimization loop is your process. Profile to find the bottleneck, plan at least 3 solutions, perform the best one, iterate until you hit your goal, then do a retrospective so you don't repeat mistakes. If you want to become the developer everyone calls when performance falls apart, this is the path. It's hard work, but it's also the fastest way to stand out in a crowded industry. Most developers avoid performance. That's your opportunity.
If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com on Git. And if Unity consulting is what you are after, book a free discovery call at https://consulting.thegamedev.Guru. Till next time.